Well, congratulations, guys. We are on the last podcast of Unit 1. So
Yeah.
you guys have stuck with us this whole time, and that's wonderful. So,
Yay.
podcast or Vodcast 1.9, we're going to continue with our dimensional analysis discussion. We need to talk about multi-dimensional problems and cubic and squared problems.
Yeah. So it's the same process, guys.
Yeah, so here's our rules.
Here we go.
Same exact rules.
Yep.
It gets a little
Nothing's
more
changed.
complex because now we're working with multiple dimensions.
Right. So instead of just starting with something in the numerator over 1, it's going to be something in the numerator and the denominator.
Yep. Okay, so the key to multidimensional problems, is to do one dimension
At a time.
at a time.
So work on the top dimension first, and then work on the bottom dimension.
So we're going to do some math with this. Now, something you can notice here, my average speed for 100 miles on a bicycle was 17.2 miles per hour. So let's do a problem with that. We've got some conversion factors here. So let's say that I started at 17.2. Now,
Miles per hour. That's the number of miles you went in 1 hour.
all right, miles per 1 hour.
Right. Now, because miles per hour is miles over hours. Never keep the units, a complex unit, in the numerator together. Always split it up.
What I often see students do is they'll write 17.2 miles / hour. There are
Oh,
no
slashies.
slashies. Do not do the slashy thing. So what I want to do, actually we haven't asked what the question is, I want to convert this to meters per second. I have a slash, I know, but I want to convert it to meters per second. So what I'm going to do is I'm just going to do a fraction, and I'm just going to do the math here.
Yeah.
So if I do miles,
But I don't know the conversion from miles per hour to meters per second.
I don't either. So I'm going to go from, I'm going to ignore hour for just a moment. Leave it right there. I'm going to go from miles, and now I'm going to go to something. How am I going to go miles?
Can we go miles to meters?
Well,
Do
let's
we
see.
have that?
No, I've got miles to
Miles
kilometers.
to kilometers, or we can go miles to feet, and then no, miles to kilometers. And yeah, let's go miles to kilometers.
So actually, I'm going to go from miles to kilometers
Yep, and
and
then
kilometers to
kilometers to
meters. Let's kind of make a little road map.
Okay.
So I can go miles to kilometers. Now let's go back and look at the number on the chart here.
1.609.
There's 1.609 kilometers in 1 mile.
Okay.
My miles cancel. And now I just keep on going on my
Right.
fraction.
Now, we can go kilometers to meters. That's easy.
I can go kilometers to meters. Now that's
Yeah.
not on my conversion
No,
table. So if
that's
I
a
go
metric
back to the
thing.
conversion table, no kilometers to meter.
No.
You're going to have to use the fact that
1,000 meters.
there's 1,000 meters
In
in
1
kilometer.
kilometer.
And the kilometer cancels.
All right, now I'm in meters on the top.
That's what I want. I want
Yeah.
meters on top,
That's
and I want
good.
seconds on the
So
bottom.
meters per hour, but that's not what we want. We want
Meters per second.
per second. So we need that hour to turn into something
I
else.
just keep going. I don't
Yeah.
stop. And I see out. Now, this is something before this moment, whenever we've
Yes.
done a problem, we've always canceled by putting a number on the bottom. We're going to put a number on the top because the rule isn't bottom,
It's opposite.
opposite. So ours is on the bottom, and I'm going to put
Hours
minutes.
to minute.
And of course, 1 hour, there are 60 minutes. Don't mix that up, by the way. It's easy to sometimes think
Yeah.
there's 60 hours in a
Now,
minute.
some people panic at this point because they don't want to cancel things out that aren't touching, but that's okay.
The hours is on the bottom.
Right.
The hours is on the top.
It doesn't matter where they are in the problem.
That's correct.
You can cancel a top to a bottom anywhere in the problem.
And now I do one more again, and I will
Yes.
just say I have the minutes on the
Minutes.
bottom. I'll put minutes on the top, and I'll put seconds on the bottom. There is 60 seconds in 1 minute.
You
Now
almost
this
put
is.
60 minutes in 1 second.
I know I didn't
I
do it.
saw it.
I was testing you.
Yeah.
All right, now this is an interesting problem because we have 3 numbers on the top and 2 on the bottom. The bottom ones are divide.
Yep.
The top ones are times. So,
Yeah.
Mr. Sams, you got the
I will
calculator?
punch in the calculator. Why don't you cancel those units out while I do that? I got 17.2 times 1.609
Times 1,000.
times 1,000 divided by 60 divided by 60. Anything in the top gets a times. Anything in the bottom gets a divided. Enter. 7. Well, how many sig figs do we want?
3
3. So I got 7.69
meters per second.
meters per second.
So on average, as going uphill, I would go slower and downhill faster. On average, on that bicycle, I was traveling 7.69 meters every second. So that's pretty fast, actually.
Yeah.
For 100 miles.
Yeah.
In big races, I'll try and travel 21, 22 miles an hour.
Wow.
But on training rides, you can't ever do that, especially with that elevation profile. Oh my gosh. Yeah, most races aren't quite that hard. All right, let's do another one. Okay. Now this is, by the way, a sample of gold over here. So gold has a density of 19.3 grams per milliliter. So 19.3 grams. No slashies over 1 milliliters. Now, our problems will have slashies,
Yeah.
but you
have
need to write
unslashy them.
unslashy them. That's a good way.
Unslashy.
So I need to convert
Your
grams
thermometer.
to pounds and milliliters to liter.
Oh, yeah.
So basically, if I had a liter of gold, like a liter bottle of pop, not a 2 liter, half of one
Right.
of those, right? How much would it weigh in pounds? It'd be an interesting question.
You got an Nalgene bottle, that's 1 liter. That's a lot of gold.
That'd be, well, let's see
How
how,
much
much
that
it weighs.
would- how much would that
We'll
weigh?
find out.
Yeah.
All right, so 19.3 grams per 1 milliliter.
All
Let's
right.
do the
I know-
mass first.
Okay.
So I got a G on the top, so
Yep.
I'll put a G on the bottom.
Yep.
I'm going to go pound.
Yeah.
Now, we've got to look at our
To our
conversion
table.
table.
Somewhere.
Forward to
Where
our
did we put
conversion. There it is.
is.
Pounds to grams. That's that 454 number. I guess,
454
right?
grams in 1 pound.
So there's 454 grams in 1 pound.
Okay,
The G's
so
cancel.
we're in
Well,
pounds.
we got pounds per milliliter.
Pounds per milliliter. We don't want pounds per milliliter. We want pounds per liter.
Now the milliliters on the bottom. Rule goes on the
Top.
and then
Liter.
There's 1,000.
1,000.
Now you got to know that. If you don't know that, you got to figure that out. And the milliliters cancel.
Yep.
So Mr. Sams, what do we come up with there?
19.3
Divided by.
divided by 454 times 1,000.
What do you get?
42.5.
42.5 pounds per liter.
That's
Wow.
My son weighs about 42 pounds.
But he's not a liter. He's a lot
No,
bigger.
he's a
than
lot
liter.
bigger than that.
But gold is one of the most dense things that exists. So this
Yeah.
is not totally surprising to me. So a liter of gold would weigh 42 pounds. -ish.
Wow.
That's a lot.
That is.
That's quite a bit. Okay, a couple more examples here. All right, 44 centimeters cubed to inches. Now we need to kind of talk
Yeah.
this through.
Now, this is not a slashy split it up thing.
yeah,
This is.
hard.
No.
Oh, all right.
It's not hard.
All right, now here I want to show you something. What is a centimeter cubed?
That's a centimeter times centimeter times centimeter.
Right, it's a box, right?
Right.
That's a centimeter by centimeter by centimeter, right?
Yeah.
And so instead of writing it centimeter cubed, I'm going to say cm, cm, cm.
Which is the same thing. We just expanded it out a little bit.
Yeah, it's the expando version.
Expando.
So
No
now-
slashies and expando.
So now I just need to convert centimeters to inches 3 times.
3 times, yeah.
So if we look at our conversion table, centimeters to inches. Here it is. 2.54 centimeters is 1 inch. So what I'm going to do is I'm going to put centimeters to inch. And we know there's 2.54 centimeters in 1 inch.
Okay.
Crosses off center. Now, am I done?
No, you got 2 more centimeters.
I've
to
got
get
to
rid of.
cancel out all 3 centimeters. I have to do this 3 times. So I'll say 2.54 centimeters is 1 inch.
So we're converting centimeters cubed to inches cubed, which is saying centimeter, centimeter, centimeter to inch.
Kind of like, yeah. Isn't there some kind of story about that?
There is.
Foot.
Yeah, foot. There's a rabbit. 3 rabbits. Ask me in class. I'll tell you
Okay.
the foot story.
So now I'm done with inch, which is an inch cubed. So
Yes.
now I'm going to take 44.
44.
Divided by.
Divided by.
2.54.
2.54.
Divided by.
Divided by.
2.54.
2.54.
Divided by.
Divided.
2.54.
1,
Equals.
2, 3, got 'em. 2.69.
2.69.
My calculator says 2.68504474.
That's not right. 44 divided by 2
Oh.
divided by 2 divided by 2.
Yeah, 44 divided
Oh,
by
that sounds right.
2.54.
Okay.
Yeah.
And that'll be inches
Oh,
cubed.
but we only want 2 sig figs.
So we'll say
44.
2.7 inches cubed.
Yep.
Okay. All right.